of square matrices, where we discussed specifically a matrix of order 2. That means 2 rows, 2 columns. So as you guys know that the formula for finding inverse of a matrix is given by this. In the previous video, we found the adjoint of a matrix by a very simple method, that was switching the diagonal entries and changing the signs of the rest of the two entries. Okay, if you want to check that out, you can go to the previous video and check out how we found the adjoint there. But in that video, I promised you that I will share with you the general method to find out the adjoint. Okay, so in this video, we are going to talk specifically about the adjoint. So I will keep my matrix same so that you guys can connect with the previous video as well. So I'm going to take the same matrix that I took in the previous video. Okay, so the inverse, as we found in that video, was given by this. Okay, you can see the process of finding this inverse. But today I'm going to describe you how we can find the adjoint of a matrix, which is the general method of finding adjoint. That means this method not only works for 2 by 2 matrices, but is also useful for 3 by 3 matrices. Okay, the method that we used for 2 by 2 matrices in the previous video, right, that will not work for the 3 by 3 matrices. Okay, so let us just begin with how to find out the adjoint. Okay, the adjoint of the matrix was given by this, and basically the formula for adjoint is matrix of cofactors transpose. Okay, do you know what is transpose? For example, I have a matrix, say 1, 3, 0, minus 2. What would be the transpose of this matrix? If you know about that, pause it here and just write down. Okay, I will tell you the answer in a minute. So, okay, I hope you have figured out, but if you don't know, then transpose is simply interchanging the rows with the columns. That means the transpose of this matrix is given by 1, 3, 0, minus 2. Isn't that easy? Okay, so that is how we find the transpose. So basically our purpose is to figure out how to find this matrix of cofactors. Okay, so let us break down the process. So let's call this matrix of cofactors K. Okay, and its elements, let's denote them by Kij. Okay, that means first I represent the row, J represent the column. Okay, now how would I define this Kij? Kij is defined by this formula. Okay, don't get scared, we will break it down step by step. Okay, look at this number. Just realize that this number is either going to be 1 or going to be minus 1, right? Because, okay, let us talk about K 1, 2. That means I is 1 and J is 2, right? In that case, let's figure out the value of this number. That means that's going to be minus 1, 1 plus 2, okay, which is minus 1 raised to the power 3. And since the power is odd, that means it's going to be a negative 1, right? And suppose we take K2, 2. Okay, and then let's figure out the value of this minus 1 to the power I plus j. Then that's going to be minus 1 to the power 2 plus 2, which is going to be minus 1 to the power 4. That is nothing but 1. That means this number can either be a positive 1 or it can be a negative 1. Okay, so that's not a problem. Now let's focus on this one. Okay, and you will realize that it is also like when you do it with the very carefully, that is also going to make sense for you. Okay, and it's not very complex. So let's figure out how to find this minor. Actually, that will be the matrix of the minors. So that is our only job to figure out. Okay, so I'm gonna take the same matrix and I have written both the formulas here. Okay, my main purpose is to figure out what is the matrix of cofactors, and for matrix of cofactors I needed to find the minors. Okay, so I'm gonna take the same matrix. Okay, so let's figure out the first row and first column element, because okay, keep one thing in mind. The matrix of cofactors, which I called K, let us call the matrix of minors as M. There is a very important thing which is common between K, M and A, that the number of rows and the number of columns is going to be the same. Okay, that means K and M both are going to be 2 by 2 matrices. So now we have to figure out this M, and hence we need to figure out the K. Okay, so to find out the first row and first column element of M, what I'm going to do, I will be hiding the first row and the first column. Are you realizing? First row, first column, I'm hiding that row and that column, and what I am left with, that is 2, right? So the first element is 2. Okay, this is how we find the minor. Okay, now how to find the first row, first element of the cofactor? That is nothing but the element of minor multiplied by 1 or minus 1, which depends on whether the power of this minus 1 is even or odd. Okay, so that means this multiplied by 2, the first row, first column element of the minor. Okay, now minus 1 raised to the power 2, that's 2 is an even number. Okay, so that's going to be a positive 1. So this is going to be 2, right? So we figured out what's the first row, first column element of the matrix of cofactors. Okay, let's figure out the second one. I mean first row, second element. Okay, just go the same way. So hide the first row of the matrix and hide the second column. What we are left with? Negative 2. Okay, over here minus 1 raised to the power 1 plus 2 multiplied by the element of minor, which is minus 2. I'll have to be very careful because I have a minus sign, right? Now this minus 1 raised to the power 3, it's an odd number, that's going to be minus 1. Okay, if I write it like this, multiplied by minus 2, and you know minus 1 minus 2 is going to be positive 2, so that's positive 2. Okay, let's figure out the second row, first column. So second row, first column, just hide the second row now and the first column, and we got it 1. And just figure out that your element of cofactor should be minus 1. Now you think why it is minus 1. Look at this formula, okay, and follow the same process as we used in the previous steps. And the last one, the second row, second element. So hide the second row, hide the second element. We got 3, but here we got 3 because of this formula. Okay, we got all the elements, and here is our matrix of cofactors, which is ready, right? This is what we wanted, okay? But our adjoint is the transpose of this matrix, okay? That means I need to take the transpose. Okay, let us take the transpose together. So that is the row which will become a column now, and here we go with the another one, right? Okay, now let's figure out our previous method. So that will also be the revision of your previous method. So as per the previous method, how we used to find out the adjoint? If you know that, just pause it here and figure out. Okay, if you don't know that, then the straight method, the right away method was switch the diagonal elements and change the sign of the rest of the elements. Oh wow, both of the matrices are the same, right? So that was the general method to find out the adjoint. Okay.